Hi everybody, welcome again to this next video. So in this one what we're going to be looking at is error intervals, and from error intervals we're then going to move on to looking at bounds. So some of this will be in foundation, some of this will be in higher, and I'll let you know exactly which bits will be in which. So let's have a look straight away. This first question says a number x, so this is a number we're talking about, has been rounded to one decimal place. The resulting answer is 6.8. Write the error interval for x. So where it says write the error interval, sometimes in your exam what it will do is it will have this down here in the corner. It will have the inequalities written for you, and then you'll just need to fill in these gaps. But sometimes it won't have that, and what you will need to do is fill that in. So the thing you need to remember is they're both less than signs, and the one on the left hand side has an additional line to it, which means it's less than or equal to. So the left has another line, you can think about it like that, left another line, less than, they're both less than, and the left hand side one has an extra line. So let's just talk through what we're going to end up getting with this question. So we know the number's 6.8, so we're going to write 6.8. And the way I want you to think about this is, you can think about this as houses, you could think about it as boxes, anything. But basically what I'm saying is I'm currently at 6.8. The next place to the right of me would be 6.9, and the previous place would be 6.7. Okay, nice way of thinking about it is imagine that you live at these places. So assuming that the houses go up just by one, if I live at 6.8, my next door neighbour is 6.9, and my other next door neighbour is 6.7. Then you can think to yourself, right, well, I hate my next door neighbours, I don't get on with them, so I'm going to build a fence. And this is where you're going to build your fence. So I'm going to build a fence here, which is at 6.75, because it's between the two. And this one will be at 6.85, because it's between the two there. Okay, so I know it's a bit of a silly example there to think about using houses, but it kind of helps you just remember and visualize it. So when you see error intervals, what you think about is you live at that location, you live that place, next door 6.9, previous one 6.7, put a fence up in the middle of both of them, so it becomes 6.75, and the top one becomes 6.85. So we would also refer to this as an upper bound, which we'll talk about a little bit later on in this video, and this would be called your lower bound. And again, we'll come back to that later. Now, why do these inequality signs matter? Well, the number is 6.8, so eventually what we need is this to round to 6.8. So the number 6.75 is less than or equal to 6.8. The reason it's less than or equal to is because if it was equal to this, the 5 would push that 7 up to an 8 to make it 6.8. However, if my number actually was 6.85, the 5 would push that up to a 9. The reason that we then have this inequality is because we're saying it has to be less than 6.85, okay? Which technically you could argue then it becomes 6.84999, and that would be reoccurring. It would just go on and on and on. But at what point would you stop here? So we use the notation of 6.85, and 6.85 is correct because we're saying it is less than 6.85. Okay, so that's how you do a basic error interval question. So I've got one here that you can have a go at. I've got two examples here for you to have a go at if you want. You can pause the video, have a go at them, and see how you get on. Okay, so looking at this one, the only thing that's different here is the fact it now says 2 decimal places. So we're still going to follow the same process. I'm going to just write down here the less than or equal to sign on the left and the less than sign for the one on the right. So 7.43 is where I live. So think about it like that. That's the place that I live at. So my next door neighbour becomes 7.44. So that's my 2 decimal places. And my previous next door neighbour is 7.42. So you can think about it like that. And the reason I'm doing that is because it's 2 decimal places now. So the 43 is the part I'm looking at. So it becomes 4442. Put your fence up in between. So this becomes 7.4, and it becomes 425 now. And this becomes 7.435, because that's the middle of 43 and 44. It's the 0.5 part. Okay, so that would be your lower bound, 7.425, and your upper bound would be 7.435. This talks about 2 decimal places, and I end up having 3 in my answer. This one spoke about 1 decimal place, and I end up having 2 in my answer. So whatever this says here, you're going to have an additional place as your answer. Okay, now this one's a little bit different because it now says it's been rounded to 3 significant figures. So you need to understand what significant figures are and how they work. But we know that that's the first significant figure, that's the second, and that's the third. So I do live at 72.5, which means my next door neighbour is going to be 72.6 because the third significant figure is the 5, the next number would be 6, and this would become 72.4. Okay, so again, going in the middle, this becomes 72 point, and then we're going to go 4, 5, because that's effectively, if you think about it, like 40, 50, and 60. Then we've got 72.55. So they are my 2 error intervals. So we'd say 72.45 is less than or equal to x, which is less than 72.55. Lower bound, upper bound. Okay, obviously I'm using x as my value here. Sometimes it might choose a different letter. It might say y, p, q. Just make sure whatever it is you put in the middle there. Okay, so that's our basic understanding of error intervals. We're going to look now at slightly different wording and how you'd answer these ones where there's a slightly different wording to it. Okay, so here there's 2 key differences. The first thing we're looking at is the fact that it says Billy uses a calculator to find the value of a number, so value of x. The answer on his calculator begins with 8.2. This is really important. So the number on the calculator has effectively been rounded, but on the calculator, the first 2 digits you see are 8.2, which means I can't now do this. I can't go 8.2 and go 8.1, and I can't go 8.3 because I couldn't possibly have 8.15 here, because on the calculator, if you imagine Billy's calculator there, it starts with 8.2. So how could it possibly be 8.15? So this process here is slightly different if you see it to do with a calculator and it begins with a digit. What you now do is you still have your x less than or equal to and less than, but this time your lower bound will be whatever that is there. And the reason is because it has to be the lowest value. 8.20, effectively you could call it, 8.20 is the absolute lowest value it could be. Okay, then that calculator still begins with 8.2. Now 8.2, it can go up to 8.299999. So therefore, again, we say our upper bound now becomes 8.3, 8.30. Okay, now obviously it couldn't be 8.35, it couldn't be anything that begins with a 3 or anything that begins with a 1, because as we look at this diagram here, it begins with 8.2. So just a very subtle change in the wording, but that's how you'd answer a question like that. And then you see this third style here. Okay, so it says a number has been truncated. It's a keyword there. It now says it's being truncated, which means it's been cut off to 1 decimal place. The resulting answer is 5.6. If you see a question that says about it being truncated, it's exactly the same as what we've done in this one here. So we say again, it has to be beginning with 5.6 because the number begins with that 0.6. It can't go lower than 0.6. And then the absolute maximum would be 5.7. Okay, so this example here of it being truncated is exactly the same as if you see it with a calculated display begins with. So just remember those 2 key things. There's a very subtle difference between that and these. Error intervals are when and the rounding part comes from if you look at questions like this. Okay, these ones you have to choose the 0.2 and the 0.3. Really subtle difference. Might be worth just going back over what I've said there, just to make sure you get your head around it. Okay, so we're now going to move on. We're going to look at some questions that are in context. And so you can see how bounds and error intervals are used in questions such as these. And we'll go through 3 different styles now. Okay, so I've just added in calculator here just on the right hand side so you can see the sums I'm going to be doing and then how I'm going to be solving these problems. Okay, right, so let's look at this first one on the left-hand side. The lengths below have been rounded to one decimal place. So as soon as you see that into a question where it tells you that lengths have been rounded or anything like that, you know you're probably going to need to use some error intervals or bounds at some point. It's asking me to find the upper and lower bound for the area of a trapezium. So the first thing to be able to unlock this question is I need to know exactly how to find the area of a trapezium, which is A plus B times by the height divided by 2. Really important that you know that formula. And A and B are your parallel sides, so it would be A and B here, and the height is obviously 5.8, okay? What we're going to do first of all is we're just going to write the upper and lower bound for each number. So the upper bound for A is going to be, so we've got 6.4 as my value. So if we go back to what we just did, 6.5 would be the next value, and 6.3 would be my previous value. So therefore that becomes 6.35, which is the middle. I'm going to call this A, and then 6.45 is my upper bound. Okay, I'm just going to zoom in a bit so you guys can see what I'm doing. So lower bound and upper bound. If I do the same for B, the B is 12.3 because A and B are your parallel sides. So 12.4 is my next value, 12.2, go in the middle, go in the middle. So it becomes 12.25 is less than or equal to B, which is less than 12.35. So upper bound, lower bound, and then we're going to do the height. So my upper bound, so it's 5.8, so 5.9, 5.7, so we're going 5.75 is my lower bound, call this H, and 5.85 as my upper bound. Okay, so what I'm going to need to be doing now is I'm just going to make these a little bit smaller, just so we've got a bit more space to work with. So that's my A values and my B values, and my H value is this one here. So I need to find the upper bound for the area. So in order to find the upper bound, so let's go over here, upper bound is going to be the upper bound of each value. So A plus B times by the height and divided by 2. So I'm choosing the upper bound of each bit. So I'm saying 6.45 plus 12.35. That's my A plus B times by the height, which is 5.85, all now divided by 2. Now this part of what we're talking about is most likely to be in higher. The previous stuff we've done in the first part of the video is more likely to be your foundation stuff that you need to know, okay? So let's just chuck this into the calculator. You can see on the right hand side here, I've got the Desmos calculator open, so I'm going to start fraction there. I'm going to open up a bracket, so I'm doing 6.45 plus my 12.35, close my bracket, times by my height, which is 5.85. So that's all upper bound. I'm just going to go back and double check. That was my upper bound, yep. That was my upper bound, yep. And that's my upper bound for the height. And then all divided by 2. And when you work that out, you get an answer of 54.99 that you can all see on the screen there. So I'm going to write that really clearly. I'm going to write upper bound there next to it. So in an exam, it's really clear to an examiner that I know that that is the upper bound for my area. Okay, I'm just going to make that a bit smaller. Move that to the side. So now I'm going to do exactly the same, but I'm going to do it for the lower bound. So for lower here, I'm going to choose the 6.35, the 12.25, and the 5.75. And I'm just plugging in exactly the same A plus my B times by my height, all divided by 2. Just be really careful you haven't accidentally crossed yourself over. So I haven't used 6.35 there and then the 12.35. So that's why I've circled them in different colours there. You can see exactly that I've used all the lower bounds. make it really, really obvious for yourself. Don't make any silly mistakes in an exam that's going to cost you. So it becomes 6.35 plus 12.25 times by the height, which is 5.75, and that gives me 53.475, as you can see there, and that's centimetres squared. And again, think to yourself, does my answer make sense? Well, that is my lower bound, so it has to be smaller, 53.475, than what I've got there, which is 54.99. So that absolutely makes sense. My upper bound is bigger than my lower bound. Okay, so that's an example of how you would solve that in a context question. Okay, what I'm going to do is just going to make that a bit smaller again, move that to the side. So we're going to then answer this question on the right hand side here to do with cylinders. Okay. Right, so this example here is far more complicated. There's a lot more involved here, and we're going to need to understand exactly what's going on, how the bounds work, and understand the context of the question. So it says each side of the cylinder has been rounded to one decimal place. So if we look here, the 2.6 and the 8.4 have been rounded to one decimal place. So in that instance, the first thing I'm going to need to think about is finding the upper bound of those values. Now this one here is my radius, and this one here is my height. Okay, so we're going to need those to find the volume in a second. So each other cylinder has been rounded to one decimal place. A container which holds 6,400 litres, rounded to the nearest 100 millilitres. So there's a separate container that holds 6,400 litres. We don't know what shape that is, but let's just imagine we've got a container like this, and inside that it's 6,400 litres to the nearest 100 millilitres. Right, 100 millilitres is that value there. So we're going to need to be rounding that at some point as well. Is filled from the cylinder. So basically what's happening is, imagine this is filled with water. Water from there is going to go into here. It says, what is the greatest number of times that this orange container could be filled from that cylinder? Right, so what this means is we're going to need to find the upper bound of the radius. So let's call that R, and the lower bound. So it's actually asking us just for the greatest. So the lower bound is not going to be necessary for this, but we're going to do it anyway. So 2.6 is my value. So we're going to go to 2.7, which means my upper bound 2.65. It's in the middle there. This would be 2.5, go in the middle, 2.55. So that is my lower bound for the radius. That is my upper bound for the radius. Okay. Then I'm going to do the same for the height. So let's do the height. Let's call that H. So it's 8.4. 8.5 is the next value. 8.3. So the middle, 8.35 and 8.45. So I've got my height, I've got my radius. I then need to do the rounding for this container. Okay, now that's 6,400 litres. It says it's 6,400 litres and it's rounded to the nearest 100 millilitres. So that's the value I'm looking at. If it's 6,400, the next 100 millilitres would be 6,500. And the previous is 6,300. So I need to go in the middle again, but this time it's going to be 6,350 and 6,450. Okay, so the container, I'm going to call the container C. The upper bound for the volume of the container is 6,450. And so that sign is less than, sorry. And the sign on the left-hand side is equal to 6,350. So I'm saying that this is the greatest possible size of the container, and this is the lowest possible size of that container. Okay, so there's a 100 milliliter swing in that. What I need to do, and this is where it's really hard to get your head around this question, I need to understand that in order to find the greatest number of times that I could fill this up, I've got to have the biggest volume here, because that will give me the most amount of water, and I've got to have the smallest volume here, because if I've got more water and I'm putting it into a smaller container, I'll be filling it up more times. So it's an example of where we have, because we're going to be doing some division in this question, it's an example of where you're going to have an upper bound divided by a lower bound. So let's go through the process. The first thing I need to do is find the volume of the cylinder. And as I said to you, this question is far more complicated, would only be on higher, would come up towards the back of the paper as well. So it wouldn't be an easy question. So the volume of the cylinder is going to be found by doing the area of the top, okay, which is a circle. So we're going to do pi times the radius squared. And the radius here is 2.6. But remember, we're using the upper bound. So it's pi times 2.65 squared. So that's the area of the top. And then times that by the height. And again, we're using the upper bound of the height, which is 8.45 meters. So we're saying the volume of this cylinder is pi times 2.65 meters squared, and then that area being multiplied by 8.45. Okay, so the volume of the cylinder is 186.4225 meters cubed now. So that is the upper bound for the volume. I don't need the lower bound for the volume of the cylinder because it's asking me for the greatest number of times I could fill it up. So it's really important. First of all, you need to understand how to find the volume of that cylinder. And the volume of the cylinder is area of the top, which is a circle, times by the height. And then from there, we need to figure out what the lower bound of the container we're filling up is. That's this 6,350. So the 186.4225 meters cubed is going to be all taken out and put into this container, but we're going to use the lower bound for the container. The next thing we need to do is convert this meters cubed into litres. And I'll put this information here for you. You can see 1 meter cubed is 1,000 litres. So that 186.4225 gets multiplied by 1,000. And I end up with 186,422.5 litres. So that is the absolute maximum that container holds. It holds 186,422.5 litres. So what I now need to do is to see how many times I can go from this water, pour it into there. How many times could I do that? And in order to find the greatest number, I need the lowest value there. So I'm doing 186,422 divided by the 6,350. And if I work that out, so let's just delete all that. So 186,422.5. I'm dividing that by 6,350. And I end up with an answer of 29.3578 times. Now, it does say filled fully, so that actually means it would be 29 times. Now, just to show you what I mean about the upper bound of the container, so the answer for this question is 29 times. If I was to change the volume of the container to its upper bound, so 6,450, 6,450, you can see there it changes it to 28.9 times, which means I can actually only fill it up 28 times. So when you choose the upper bound of this value and divide it by the upper bound of this value, we end up with a smaller number. So it's really important to remember whenever you're doing division with bounds, and this is definitely worth writing down as a keynote for your revision, whenever there's division involved with bounds, you must make sure you understand that to find the upper bound, you have to do the upper bound divided by the lower bound. And if you're looking for a lower bound, you have to do the lower bound divided by the upper bound. So here, a bigger number divided by a smaller number will give you a bigger number, and a lower number divided by a bigger number will give you a smaller number. Okay. One more example we're going to look at is this one down here. So, I mean, you could pause the video here and have a go at this yourself if you wanted to, thinking about using this information that I've just given you. It would be worth you having a go at it and trying to do this last bit yourself. If not, I'm going to go through it now anyway, but if you want to pause the video and give it a go yourself, you can. Okay, so final bit here, let's have a little look at what we've got. So it says the formula to find S is as follows. So here's my formula. S is equal to R squared divided by 2 lots of Q. And it tells you here that R is 4.7 and Q is 3.2. Each value's been rounded to 1 decimal place. So we know that bit there is going to be important, that 1 decimal place, because that's going to be what we have to talk about in terms of bounds. By considering bounds, find the greatest and least value of S. Okay, cool. So first of all, 4.7, let's go through our process again. 4.7, 4.8, 4.6. Okay, just going to zoom in here. So therefore, we know that R, and always make sure you write this down, is 4.75 as an upper bound, and then 4.65 as a lower bound. So we've got R. Next, do the same for Q. So put Q in the middle. 3.2 is what we had. So 3.2 goes to 3.3, 3.1. So in the middle, 3.15, and here, 3.25. Okay, so you've got your upper bound and you've got your lower bound for Q and R. So we're going to find out upper bound for S first of all. And remember what I've said up the top here. To find your upper bound, you're going to do the upper bound divided by the lower bound, which means I'm saying the upper bound of R, which we know is 4.75. So I'm saying 4.75 squared divided by, and I'm taking the lower bound now of Q because I'm going to do a bigger number divided by a smaller number. 2 times 3.15. It's so important in these questions as well that you make sure you show all your working out and don't just type it in a calculator to get the answer. So 3.75 squared divided by 2.32 times 3.15. Okay, when I work that out, I'm saying my upper, and you can see what I've done on the right hand side there. So 4.75 squared divided by 2 times 3.15 gives me 3.581349,206. I'm writing all those digits down so I know I'm not going to mess anything up or make any mistakes. So that is my upper bound, I'm saying. So now what I need to do is do the same for the lower bound. So to do the lower bound, we're going to say lower bound divided by upper bound. So now I take my lower bound of R, which is 4.65. So 4.65 squared, and I divide it by my upper bound now of Q. I'll do this in a different color to make it clearer for you. So the 3.25 there, so it's 2 times the 3.25. Again, think about the logic there. Smaller number divided by a bigger number will give you a smaller number. And I'll show it to you now as we do the answer. So it's going to become 4.65 squared divided by 2 times 3.25. And you can see my answer actually is smaller. So 3.326538. 326538.462. So this is my upper bound for the value of S. This is my lower bound for the value of S. Now, a lot of the time in an exam, what you'll find is that these two numbers might round to a similar number. So they both might round to something like 3.5, or they both might round to 3.6 or something. But because they both don't round to a particular number, I can't leave my answer in any other way. I'm just going to leave it as 3.58 as my upper bound and 3.33 you could say for your lower bound, depending on what it's asking you to do. Okay, so that's everything to do with bounds. we've gone through the very basic understanding of error intervals there and making sure you understand how to find the upper bound and the lower bound from doing that. Think about your houses. Here, if it says truncated or that the calculator begins with on a display, that's how you'd answer those ones. And then here we've gone through a couple of examples in context. I'd say you're looking at things like this question here and this question here, common and higher. But you could be asked a question just purely about area as well. Okay, hope you found that useful. Hope it helped you, and I'll see you guys in the next video.